All right, today we are going over some algebra basics, linear functions. Let's begin. And you may recall the equation y equals mx plus b, and we'll be exploring that on our next slide. So here I went ahead and gave you y is equal to mx plus b in Desmos, and I want you to go ahead and move around the m slider. Take a look at what's happening, because originally I started right here, all right, at our linear parent function. But as I moved it to the right, and then whenever I moved it to the left, interesting. Ooh, and then far left, wow, okay. So it looks like, then whenever I change the b, oh, look at that. As I move it to the right, it looks almost like it's moving up. But then whenever I move it to the left, interesting. So what I'd like you to do next is in here, go ahead and type away. Just some observations that you notice whenever you change the m and whenever you change the b. Okay, so whenever you change the m, what happened to the line? What happened to the line whenever you adjusted the b value? And then once you finish typing, click Share with Class. And continuing, parts of the sorry, one moment. Actually, sorry, I'll just go back and rewrite that. I didn't realize I was still recording. Okay, so given y is equal, and I'll rewrite that one more time, 5x plus 2, you will locate your coefficient right here as the number in front of the x variable. 5 and x are being multiplied, so the 5 in front of the x is called its coefficient. All right, any other numbers, like if here's a number that's alone, it's by itself, it has no variable, you would call that a constant. All right, so going back, you may also recall the following formulas for slope. Now, this we haven't seen in a while, but everyone remembers rise over run. Now, whenever it comes to rise, you are going up if you have a positive number, but you're going to go down if your number in the rise area is negative. Now, run, just to keep things simple, because that's where a lot of people function up, run, just always run from left to right. Keep that one positive, and the only negative one you'll have is in your rise, and that will keep it so much easier. You may possibly remember the formula for slope, which is y sub 2 minus y sub 1 minus x sub 2 over x sub 1. We'll be using that. And another way to shorthand that formula is by saying delta y over delta x. Now, in case you forgot, delta, that triangle symbol, that means change. All right, so that's why we're subtracting. We're finding the change in our y's and our change in our x's. Now, we did manipulate our b value, and we noticed that it caused the line to either shift up or shift down. The reason for that is the b value is actually our y-intercept. In case you forgot what that meant, that's actually going to, oh, sorry, that's on the next one. You can identify the y-intercept as the constant, kind of like I had shown you in this equation, the y equals 5, and that's the slope, x. And then in blue, I'm going to put my y-intercept of plus 2. That's a positive 2. Now, this is the constant. That's a solo number. It's not attached to any variable. And it's usually at the end of the equation, if it's in slope-intercept form. Now, there we go. Y-intercepts can be located on the graph where the line crosses the y-axis. So, let's draw an xy axis. That's x, and that's y. And I'm going to draw a line. So your y-intercept is going to be located on the graph where the line crosses the y-axis, right here. That is your y-intercept. Last thing to note, your y-intercept, they are coordinates, and they should be represented with 0, comma, and then that number. So for y is equal to 5x plus 2, my y-intercept, I'm going to write with a marker because it looks better, would be parentheses 0, comma 2. Now, if that were a negative 2, then I would put, or minus 2, I would put the negative there. But because it's positive, I don't have to write plus 2 there. All right, continuing. Now on this slide, I went ahead and gave you a whole bunch of different graphs and slopes and y-intercepts. Now, this activity is much easier to do on a computer, but I understand not all of you guys have computers. So for those of you who are doing this activity on your cell phone, you might notice that everything's kind of stacked on top of each other. So this is what I would recommend. Grab all of the graphs. Now you'll notice that whenever you stack them, it'll connect and say 2 cards. I'm going to grab all of my graphs and I'm going to put them in one stack. Now the cool thing is, you see this little arrow? If you push it, there you go, it collapses. So now I'm going to get all of my B's, those are my y-intercepts, and I'm going to stack them up. And it doesn't matter the order because I just want to make sure that I have all of them stacked up. Now I have 6 graphs, so I should have 6 y-intercepts as well. And I should also have 6 slopes. So let's just make sure that we have everything. Okay, so the best thing to do is if you're using a cell phone, you might want to collapse these and have them in a certain order. There we go. So I'm going to open up my graphs and pull out one graph, and then collapse it again. Now, I'm going to look at my graph, and I would say the easiest thing to locate on a graph would probably be the y-intercept. Now, if you can't see it very well, you click on it, and it zooms it up. There we go. So I can find my y-intercept a little bit easier, and I would locate it right here. Now, once I have identified the correct y-intercept, I go ahead and I stack it up with it. Now, that's only part of it. I also need to locate the correct slope. Now, I'm going to let you guys, I already gave you guys the y-intercept. So let's say that this is obviously not correct, that this is the correct slope. I would put it on here, and there we go. I have 3 cards. I'm done with that one. I'm going to pull out a new graph and then start all over again until I have all 6 of my 3 card stacks. All right, so you're going to be stacking the correct slope and y-intercept on top. Make sure that it stacks up together and tells you 3 cards. Now, like I said, this one was obviously wrong, so I'm going to put it back over here. I have to open it up though, sorry. There we go. I just want to show you guys how to use this portion, this card sort. So next, let's move on to our slide 6. Now, what observations can you make by manipulating the slides on the 2 equations? Now, I'm going to mess with my purple equation here. So it says y is equal to 0. You see, y is equal to 0. Now, I only want you to focus on this equation right here. Don't worry about these variables over here. That might get a little confusing. So whenever it's y is equal to 0, as a matter of fact, I'm going to take off that red line right there so I won't get confused. I'm only dealing with y is equal to 0. I have a purple line going across over here. And then I'm going to shift it. I'm going to move my little circle over to the right. And it looks like it's moving it up. But whenever I move it to the left, it looks like it's moving it down. Now, there are no other changes to my equation here. Just as this number changes, my line moves up and down. So let's take a look at the red line. Right now, my red line is x is equal to 0. And it gives me another line going across this way this time. Now it says x is equal to 0. Now it says x is equal to 1. Okay. X is equal to 1.5. X is equal to 2.5. X is equal to, oh goodness, 3. All right. Let's go over to x is equal to negative 1-ish. There we go. Interesting. Okay, so let's move on to the next slide. You guys might recall this Hoy Vux. You probably went over it in middle school, definitely in Algebra 1, but I know a lot of people got confused with it, kind of forgot what it meant, so let's go over it. Now, H is obviously for horizontal. Now, a horizontal line goes in this direction, left to right. So a horizontal line goes across this way. Now, whenever you have a horizontal line, your slope is equivalent to 0. And that will happen whenever you have an equation that begins with y equals. Just like our purple line, it said y was equal to negative 2, and it made a horizontal line, and it crossed my y-axis at negative 2. So to summarize, equations that begin with y equals and only have a constant, cough, cough, a number without a variable, so like y is equal to negative 2, they create a horizontal line because its slope is 0. It's not going to rise and then run. It doesn't rise, but it continues to run, okay? So that's why we have a horizontal line. Let's talk about Vux, all right? So Hoy is obviously talking about horizontal lines with a 0 slope begin with y equals. So Vux obviously must be talking about vertical lines. In case you forgot what direction vertical is, it's up and down. Yeah. So whenever you have a line that goes up and down, its slope is actually undefined. All right. You guys might remember that slope guy or slope man. Now, this will occur whenever you have an equation that begins with x equals. So think of our red line. We had our red line running up and down, and we stopped at x is equal to negative 1. So that means that my vertical line crossed my x-axis at negative 1. So equations that begin with x equals and only have a constant create a vertical line. These types of lines have an undefined slope. So if I were to ask you what the slope would be, you would say undefined. So just like last time, you have another card sort. If you want, you can put together all of your x equals equations, which are just 3 of them. Then you have your y equal equations, and then you have a whole bunch of graphs. Now, the way I would probably separate them so that I can make it quicker, I would probably put together all of my horizontal lines and all of my vertical lines. Because then you can go back over here, review over this, and find out, oh, horizontal lines begin with cough, cough, y equals. So, if I were to, I'm pretty sure it messed everything up again. So if I have a horizontal line, I know that it must be one of these y equals equations. So if I have a vertical line, it must be one of these x equals equations. Now remember, you're going to get the graph and then take the equation that correctly corresponds with the graph and click them together. That's how you'll get a correct grade. And you're going to do that for all 6 of these graphs. Now, I went ahead and showed you a little example of what that looks like whenever it clicks all together. So your last card sort, you are going to be taking an, okay, sorry, I was trying to zoom in a little bit more, but it won't let me. So you're going to start with an equation. All right. Now, this is why I love Desmos, because you can write all over things. Now, from the equation, you want to identify the correct graph. All right, so you're going to match the graph. Now, what I would choose to do next is you could probably find the slope and y-intercept from your equation, because this says y equals negative x plus 1. So it's implied that I have a slope of -1. So here's my slope. And then, of course, my y-intercept would be 0, +1. Now, to get my table and my x-intercept, I would probably just look at my graph, kind of zoom in and see, oh, well, there's my x-intercept. And I would make sure that all of my points are on my table are represented on the graph. Okay, so that's why I did a whole example just for y'all so you could take a look at it. And now, there we go. Now you notice there is so much stuff here. Even on a computer, it might get a little confusing. So you might want to, again, organize yourself, get all of your graphs together. I believe there are only, there's only 3 graphs and 3 tables. I think I messed up on that. Oh, yeah, I did mess up on that. Let me get my 1, 2, 3. You know, I saw my 3rd one somewhere. Here we go. My 3 equations. And then my 1, 2. You know, I have a 3rd x-intercept somewhere. There it is. Okay. Then my y-intercepts. Oh, there it is. And here are my tables. Now I can actually see everything. Now you'll notice it got a little messy really quickly, okay? So like I stated, you may want to start with looking at your graphs, since you only have 3 of them here, and the equations. So that's how you can start putting them together quickly. Now, if you're like, I'm able to recognize my y-intercept and my slope quicker, well, then go ahead and do that. So if you are able to recognize your slope, cough, cough, and your y-intercept, and you want to match all those 3 together, you can. It doesn't matter the order, just as long as you get all of these correctly matched up, just like I showed on the previous slide here, okay? So the equation has to match the graph, table, slope, y-intercept, and x-intercept. Now, once you have done that, that's whenever you go back into Google Classroom and then you click Mark as done, okay? Don't be clicking Mark as done for your attendance, because then that gives you a 0 for your actual grade. Okay, you have to finish this first, this Desmos activity, and then you come in and mark as done, and I'll go in and put in your grade. All right, so I'll see you guys tomorrow.